Yes, sir.
You're able to see my screen, right? So last time we were talking about different values or data related to our own design, right? Which is very essential in explaining the challenges we faced, the design that we have run, and the solutions we provided, the fixes we have done, etc. Right? So in line with these, I wanted you to come up with these values, right? At every stage, what would be my instance count, utilization, congestion numbers, uncertainty, right? And setup and hold violations, DRVs, right? And shorts and DRCs will only come at a route stage or post route stage. You guys are able to go back, check your designs and populate values for these. I mean, not all values will be existing. For example, at place stage and floor plan stage, you will not have any hold violations. You will not have any shorts and DRCs. So that you can leave empty. But other things, were you able to come up with the values? Yes, I'm hearing silence. You need to speak up, guys. I won't attend the interview. You guys will attend the
Yeah,
interviews,
yes, sir.
right? Oh, you are able to get the values. Okay, great.
Sir,
Others?
what is uncertainty, sir, in that table column?
What is uncertainty?
Yeah, we know
Okay.
clock uncertainty, but every
Mhm.
stage is bonus.
No, no, from clock only. Like I said, uncertainty will be from clock. Okay, CTS, post CTS, and post route. These three stages, uncertainty should be fine. Yeah, so clock uncertainty itself, it will start from place stage, then CTS, then post CTS, and then post route. You were present for the last class.
Yeah, yes, sir.
Okay, uncertainty. So uncertainty is essentially a combination of skew, jitter, and some margin. Margin is nothing but your slack. They want to increase the slack if you don't have a realistic value, right? So for now, you can um, you can forget margin and only concentrate on skew and jitter. So we were talking about different stages: place stage, CTS stage, route stage, right? At place stage, I will not have any clock. Am I right?
Yeah, yes,
Yeah.
sir.
Yeah. And I will not have any routing also, right? So I don't have clock and I don't have routing. I only have estimated RC values for routing. I will only have estimated RC values for routing. And clock is also not built, right? I will have zero skew essentially, right? So at play stage, whatever I'm doing to my design, whatever optimization I'm doing to my design, I am just assuming skew as zero and I am just assuming the RC values. But in the later stages, I will get actual clock and actual net delays, right? So since I don't, since there are unknowns in my play stage, I will add something called as uncertainty. I will add something called as uncertainty. For example, I have a start flop, I have an end flop, right? Let us say 1 nanosecond is my clock period. So T clock to Q. First. Let us say T combi is 800 PS or 900 PS. T clock to Q is some 50 PS, and T setup time is 30 PS. So now what is the equation for setup? T clock to Q plus T combi plus T setup should be less than or equal to, yeah, should be less than or equal to what?
T clock.
T clock is nothing but 1 ns. Is that correct? As simple as this, my T clock to Q plus T combi plus T setup should be less than or equal to T clock, which is 1 ns. Now if I add these up, I will get 980. Right? So is my setup passing or failing? Yes, guys. Is my setup passing or failing? Is my path failing setup or passing setup?
Passing, sir.
It is
Passing
passing,
setup.
right? Yeah. This is pretty good since my setup is passing. But what I don't have at this stage is I don't have the clock and I don't have the routing. I'm only, if I say 900 PS, I'm only assuming the RC. And if I say whatever is my latency and skew is 0, I'm taking skew as 0 if you see here. So that is also not true, correct? Unknowns. And I am uncertain that this path will close at later stages of the design. So remember this, I am uncertain that this path will close in the later stages of the design when actual clock is built and actual routing comes into place. I will add something called as uncertainty, right? This I will have a value, let us say 200 PS. Now what I will do is this uncertainty, what is the skew here now? 980 PS, 1000 PS, it is 20 PS, right? I will simply subtract the uncertainty value from the skew. What will it be? So here the skew is, sorry, slack, not the skew. Here the slack is positive 20 PS. Okay. I will just add pessimism to my slack because I don't know clock and I don't know routing. So now my path is failing, right? When I go to clock, when I go to CTS, I will have my clock built. I don't have my routing, right? So my number of unknowns reduced. My number of unknowns reduced. What I will do, instead of 200 PS of uncertainty, but still I have unknowns. So my 200 PS uncertainty at play stage, I will reduce it to 150 PS. Why? Because now I have clock, right? Moving on to route, I will have both clock as well as route. So my number of unknowns further reduced. But in clock, if you see, I have two components. One is skew, one is jitter. What is jitter?
Temporary variation in based on the PVT, sir.
Temporary impulsive variation in my clock pulse, right?
Sir.
So how can I estimate jitter before the actual functioning of the PLL? I cannot, right? I cannot model my jitter in my physical design itself. Skew I will know, but jitter I cannot know, right? That is why even at route stage, I will still have unknowns. Although I have route and clock built in, but still there are some unknowns. So at route stage also I will have some uncertainty. But since the number of unknowns are less, I will put less uncertainty than CTS. And for CTS, I will put less uncertainty than place. Understood? Uncertainty or any doubts? Understood uncertainty, everyone? I'm hearing only one person.
Yeah. Yes, sir.
That is, yeah, Lokesh is answering.
Yes.
Yes, Syed. Yes. Uncertainty. Yeah, uncertainty will be there at floor plan, place. Floor plan will not have a. If you want to dump timing reports pre-place, you will have uncertainty there also. At play stage, you will have uncertainty CTS, post CTS, and route. Right? Congestion we have discussed. Anyone wants a repeat of the congestion? What is congestion and all? No. Utilization. This is a very important number. Utilization. For example, in your interviews, if you say I worked on a 45 nm design or a 28 nm design, I worked on a 28 nm technology node, my utilization is 50%. Okay, immediately that guy will come to know, okay, this guy is just bluffing, because utilization for technology nodes, utilization will have a range of values of where to start and where to end, right? There will always be outliers, but usually you will have for a particular technology node or for a set of technology nodes, let us say between 16 nm to 28 nm, you will have certain utilization numbers, starting utilization I'm talking about. And if you come to 7 nm, 5 nm and all, you will have to start with much lower utilization numbers. Let us say you have worked on 28 nm, your starting utilization is 65%. Now, if you are working on a 7 nm or a 5 nm project, your starting utilization, you have to start at 55 or 50%, right? So if you are, if you say I have worked on a 5 nm project, and if you say my starting utilization is 70%, either you will get too many shots in your design or you are lying to the interviewer, right? So this is why utilization is a very, very important number in your design, right? If possible, try to go back to your designs, either it is Leon or Orca top, get the utilization numbers from floor plan to post route. Utilization will also depend on the block size and shape that you give, right? If someone is designing the block with size of 100 by 100 microns, and just for a trial sake, you just increase the size of the block to 300 by 300 microns, obviously your utilization will be much lower, right? But in real time designs, do you think will any of the clients or your management will let you increase the size of your block? Do you think they will let you increase the size of the block? No,
No,
right?
sir.
They would want you to shrink as much as possible because area is one of the main factors for cutting the cost of my chip, right? We are optimizing for PPA. We just cannot increase the area of the chip, right? So get your utilization numbers. So some of these are very, um, very important. The uncertainty values, the utilization values, right? Your TRAN limit of the design. These are very important numbers. Setup and hold violations, it is still fine. Somebody says I have 100 setup violations. Somebody else says I have 250 or 300 setup violations. It is possible. Not a big deal, right? So it depends on your floor plan, it depends on your placement, etc., etc. But utilization, uncertainty, and transition limit, these things will not vary from run to run or trial to trial, right? So try to get these numbers and make them handy.